Hello, my name is John Bozard, and this is my Physics 2212 Lab 2 on lines of charge. The goal of this lab is to build off Lab 1 by creating a computational model of two charged tapes exerting an electric force on each other. It is important to note that instead of treating each tape as a point charge, I will be using the ideas of distributed charge and superposition to determine a more accurate tape charge value. Similar to Lab 1, it is safe to assume that air resistance on tape B is negligible, the tapes will have the same charge, and the net force on the floating tape in the y direction will be 0 at equilibrium. On the right, you can see the general differences between Labs 1 and 2. Important physics concepts implemented in this lab include Newton's second law, or F equals ma, the force of gravity, Fg equals mass times acceleration due to gravity times direction vector j hat, Coulomb's law, which determines the electric force between two charges, and superposition, the method of adding together the electric force at many points to determine an overall force exerted on a system, in this case, the two tapes. Because the physical procedure for this lab is identical to Lab 1, we can use the same data to analyze the change in tape charge. As a quick recap, my tapes were 0.191 by 0.019 meters and had a mass of 1.9 times 10 to the negative 4th kilograms. The distance between them, as seen in the picture below, was 2.8 centimeters. The two U-tapes will be positively charged because they repelled each other, but also were attracted to a negatively charged pen. Newton's third law says that at equilibrium, the magnitude of the force of gravity at tape B is equal to the electric force on B due to tape A. In Lab 1, I used this knowledge to isolate and solve for the tape charge Q. In this lab, however, I was unable to do so because the tapes are no longer point charges. First in my Glowscript code, I entered my constants, like mass, acceleration due to gravity, and k. Next is the E-field function used in both Lab 0 and Lab 1, that is necessary for electric force calculations. The scale factors in the middle were altered until my arrows in the visual model were the correct size. In the bottom left is a given line charge function that essentially splits the tapes into n segments that can each be treated as point charges. For my code, n equals 10. On the right are two for loops that model the method of superposition. They calculate the electric force on each of the 10 segments and continuously add the value to the overall electric force on the floating tape, which we want to equal the gravitational force. The code above and below these loops are objects and arrow definitions that make visual analysis much easier. If you want to take a closer look at the code, it is linked in the description of this video. Here are the computational models of the experiment when using the Q determined by Lab 1 and the Q calculated by trial and error in this lab. The latter was found once the electric force was equal to the gravitational force. The numerical differences between the two tape charges can be seen above each model, and their effects on the total electric force can be observed in the white text box below. For further clarification, the green arrows represent the electric forces on each of tape B's 10-point charges by those of tape A. The white arrow represents the total electric force on B by A, and the yellow arrow represents the gravitational force on tape B. To answer the what if question, we need to compare the tape charge values from Labs 1 and 2. Because the visual differences can be seen in the previous slide, I decided to look at the percent increase. As seen from the formula, the line charge Q is 107% greater, or over 2 times the point charge value. So, why are they so different, and which is more accurate? Well, they differ because of how they were calculated. The Glowscript code does a good job of showing the change in numerical complexity. The line charge calculation will be more accurate because superposition is used to sum the multiple point charges rather than just looking at one. Furthermore, if I had used n equals 100 instead of n equals 10, the final tape charge value would be even more accurate. Thank you for watching.